fiber has a lot of advantage over copper wire. It's in terms of its efficiency and safety in transmitting signal. Optical fiber is mostly used to transmit information for a long distance because its building cost and material cost is much more expensive than copper wire. In terms of efficiency, optical fiber makes use of light and therefore has immunity to electromagnetic interference, while copper wire does not. That's why it favors the usage of optical fiber near utility pipes and railway tracks. Therefore, optical fiber is less prone to signal attenuation and has a high efficiency and accuracy in transmitting information. Moreover, because of its extraordinarily high transmitting capacity, which is around 43 terahertz nowadays, optical fiber has become one of the most popular transmitting materials in the world. Traditionally, it's difficult to have copper wires built near inflammable areas, such as gas stations, as transmitting electrical energy may induce sparks and cause explosion. Nowadays, optical fiber has full ability to resolve this problem as it guarantees no sparks during transmission. On the other hand, due to the high resistance of optical fiber, it is rather safe to use in areas near high voltage system than that of copper wire. Due to its light weight, optical fiber is widely used in aircrafts. Its small cable size also contributes to construction and networking of cable wires in existing buildings. Other minor things will be the lack of property of transmitting electrical power together with signal. With all the advantages as mentioned above, optical fiber is used widely with various applications nowadays. Today we are going to give you a brief account on the application of optical fiber communication, optical illumination, fiber optic sensor, and optical imaging in endoscopy. First of all, optical fiber communication make use of light impulse as a media to transmit signal. Optical transmitter convert electrical signal into light impulse, while the optical receiver will convert the light impulse back into the electrical impulse. Computers, television, and cable TV companies make use of this technology to transmit signals nowadays. On the other hand, as Christmas is approaching, it is not difficult that we will be able to see many decorations and illuminations. This is also one of the most popular applications of optical fiber. They are also used as light guides and other medical purposes, which will be discussed later. Remote sensor make use of the technology of optical fiber sensor. Optical fibers can be used as sensor to measure strain, temperature, pressure, and other physical quantities by modifying a fiber so that the quantity to be measured modulates the property of the light, such as the intensity, phase, polarization, wavelength, etc. A change in the property of light signal will indicate a change in these physical properties. Another common use is the fiber optic sensor in advanced intrusion detection security system. This system will detect the disturbance by modulating the light signal. If there is any disturbance, the intrusion has occurred and an alarm is triggered by the fiber optic security system. And lastly, another useful application is optical imaging. They are often built as coherent bundle of fibers together of lenses. As they are long, thin imaging devices, it enables us to view objects through a small hole. In medical aspect, this can minimize the invasive exploratory and surgical procedures. It is also possible to inspect anything difficult to reach in the industrial aspect. And that's all for our presentation. And hope that all of you will have a deeper understanding about optical fiber.
Okay, thank you. Very good. Any questions? Yes, please. Yes, please.
I want to ask, how can we ensure that the light travel in way like internal light reflection? I mean, how can we ensure that the light can travel in the optical fiber but not go out?
That is, you want to ask how total internal reflection take place over the route.
I know how it takes place, but because the optical fibers to maybe will beg if we want to transmit our signal, right?
And because first
It
thing,
is not straight.
in the past, why optical fiber is not practical because we do not figure out any materials that can give a particular refresh and index that ensure that in any angle or any temperature, total internal reflection takes place all along the routes. And one more thing is that when we produce optical fibers, we include, there are 3 layers. One is core, and then there is cladding, and the ultimate layer is protecting layer. So that these 3 layers ensure that light would be contained and retained in the fiber instead of going out. Can I answer your question?
If the fiber bends too much, the light will leak. So there's some minimum radius that you cannot go beyond the bending. So if it bends a little bit, the light can be trapped. But if it bends too much, then light will be lost. So it's indeed true.
That means if we want to use the optical fiber, we cannot bend it too much.
You cannot bend it too much, that's right. Yes. Okay. I think it's a pretty good introduction, and it gives a pretty good overview of the flux side from the history to some mechanism to applications and so forth. I think that's very good. In spring semester, that's what I teach. I teach optical communications as a 300 level course in spring, and I teach 001 in fall. So I think this is a pretty good 15-minute intro to the topic.